Hello, everyone. Let us talk about not only myself, but also about the Batch Companion, USB, Compose, and all of the beautiful things that happened yesterday afternoon and in the night while having at least one monster too many. Welcome. My name is Mario, and this is a part of actually, I think, a series of 3 talks now where I'm exploring how those beautiful little electronic badges can be programmed with Android. I'm just getting very excited about like digital things that I can connect to Android and find out how they work in depth and what we can take them with us for. So just to get us all on the same page, right? So imagine yourself being in the Berlin DroidCon in, what was it, June this year. We actually started giving out those badges, right? Those are digital badges you connect to your phone, and you could get one when you contribute code. So you had to write code, and then you could be one of the lucky 100 ones who actually got one of the digital badges. But spoilers, that might not be the only way how you can get badges. But once you had fingers on one of the badges, you connected them with the USB-C adapter to your phone and then can program them using the Android app we actually developed at the DroidCon, right? So everybody who came to us, made a PR, got a badge. What did they need to do? They needed to understand how does the commands protocol work, right? So like, how do I send data from the badge, from the phone to actually the badge, right? And therefore we thought like, hey, zeros and ones are nice, but maybe we can also like use something else that are called strings. Right? So we built a string that has a type, we called it name for some reason, that is telling the badge what to do with the rest of the data we are sending through. So in this case, we decided there should be a preview command with the name preview that has some metadata, like how big is the image or whatnot, and then the actual payload in base64 zipped format that we send over the wire so that the badge then can understand it, take it apart, and actually display something on the badge. What do you want to display on the badge is actually up to you, right? Ideally, it's the name, because that could be kind of useful for somebody else seeing you with the badge, but it could be something else. It could be weather, it could be a QR code, it could be a barcode, and whatever else, like also people were contributing to the badge at the DroidCon Berlin. I studied computer graphics, so I also obviously have to talk about computer graphics. So the badge is able to only show black and white pixels. So there is no gray. Like it's either or. It's binary. It's what we love, right? So how do you take an image and make it so that the black and white are reflecting whatever you are seeing there if you don't have the colors available? This process is called dithering, and we were able to write an algorithm for this that takes this beautiful image that has all of the colors at least once in there and transforms it over into the other black and white image. You see here that you see a bit of the livelihood of the colorful image. It's also preserved in the black and white one. One of the algorithms we were implementing is actually called Floyd-Steinberg. And there is a matrix in there. I made this joke before, I will do it again. Not be scared by the matrix, right? It's just math. It just tells you like, hey, okay, the star is the current pixel. How do I distribute the error I made to the surrounding pixels? So this is one of the algorithms we implemented there. And when I say we, I obviously mean parts of you, but everybody else, because at the booth you are seeing here in Berlin, you were coming over to us and just contributing code. This code is open source, and everybody can still contribute to it if they like. But with everything, it's not only fun to write algorithms in a language you might understand or not, but it's also fun to find out like what are the circumstances, right? Like I was saying, we had like 100 badges. So one of us had the challenging task to prepare all of those 100 badges. What needs to be done is like you need to flash an image onto the badges that runs CircuitPython. and then you also have to put the code actually on it. So I thought, hey, I can automate things. So I automated it on my Fedora Linux machine that is working for me and me only. Therefore, like it's good to be able to write a Python script that does the flashing for you, but maybe there's a way to extract it. Like maybe the logic used there can be also used like in different circumstances, different programming languages, different styles. And the same is actually also true for the beautiful black and white image algorithm I created before, right? So like taking inspiration from Floyd Steinberg, I was thinking, cool, this works on Android right now, but is there a way to take it outside? Like, not for a walk, but for like using it in different circumstances. Can I use it on a desktop app? Can I use it on something weird, like a terminal or something? And the last question is like, there's no KMP. Well, why is there no KMP in this app right now? Everybody should be doing KMP, Kotlin multiplatform, or not. You know, reasons are always fluid. So like this was one of my reasons to actually like also progress with the talk here. So let's add Kotlin multiplatform to this thing, right? So the idea is that we are taking the algorithms we've written on Android and make them available outside. So what does this mean? You need to split the code that is platform dependent from the platform independent code. And there are talks about the specifics here, but I also, just as an overview for you to look in further, I want to explain a bit more how the technical details are for actually making this dependent and independent parts of the code work together. Also, I always wanted to find out, like, how does compose for desktop actually work? Like, how can I build a desktop app without touching Swing, AWT, or whatever the fancy frameworks were that I forgot not enough about. Great learning experiences all of the way. So let's just dive down deeper. I also like to draw boxes. I hope you appreciate me drawing boxes on this beautiful diagram because this is how I imagined the app to be, right? So we have the green parts. Those are the applications a user will start, right? This will be the Android app they're having on their phone. This could be the desktop app, or this could be the terminal they're currently starting and then just executing a command on there. All of those applications will be talking to the library. That is the part where everything that is platform independent lives. So like everything that takes a buffered image and turns it into an int buffer, anything that like does the dithering will be in there. But then we also have the platform dependent parts, right? So it's way different how you're talking USB on an Android phone than you're talking USB on a Mac or on a Linux machine. So those we have to separate into like dedicated modules. And this is where a nice feature from Kotlin multiplatform comes in. I posted there a quick function that you shouldn't use this way, but it's just for elaborating how it could be working. The function is called getPlatform and is, except for the usual classical function modifier, it also has something called expect in front of it. So it expects something, right? And what it expects is the name of the platform following the name of the function. And as a terminal, I expect that I can just call this function and get the name of the platform back. And the interesting thing is like, how does this mapping work, right? So like if I have a terminal app I want to run, it sees this code, I'm summarizing it harshly, and then takes a look for the actual yellow implementation with the actual keyword and sees like, hey, what is the actual implementation of the function I'm calling? So in this case, it just returns a string. And this is the principle how you can separate dependent from independent part in your code. And since sometimes it's better to dive down a bit more, I wanted to also explain the same principle with a bit more of a complicated example. So in this case, we start again from the start and just say like, okay, I want to define like the interaction with the badge, right? So I declare an interface that is called badge manager that gives me two functionalities for all of the badges I want to use. I can send a payload and I can find out, is there actually a badge connected? And once I have defined those interfaces, I can use, again, the actual and expected keywords to define more specific things. In this case, because I feel a bit of Android coming through, I know that I need an environment. Right? I need something that helps me configuring how the applications will run. So I'm expecting a class environment. But also, additionally to this one, I'm expecting a factory function that will give me an actual batch manager. So I will write down the last function like you see on the screen right now. This is an expect function, similar to the platform thing, where I expect every implementation module to just provide me a specific batch manager for Linux, Android, sorry for hitting you in your head, and all of the beautiful things. Again, from calling it from the Android side of things, you are seeing that like I can just use it as any other function, right? I'm saying in the top line that the build manager just gets an environment that contains an actual context, because as you are Android developers, you know for everything important you want to do, you need at least one context. This looks interesting, but for me it was fascinating to find out like how do I actually define the environment, right? So like in the expect class environment, I just say like there should be some class called environment somewhere. So if I take a look again at the Android specific code downstairs there, I can say that the actual class I'm using whenever I'm compiling an Android app will be a data class called environment with only one field inside. And this field is the context I need. So this one is very nice. And also I cannot use it only for the data classes or the classes I'm expecting, but I can also override the builder function. And in this case, it gives me back the environment I was expecting and also builds an Android-specific batch manager. I hear you asking loudly, but what does the Android batch manager do? Let me go over to the next slide and just highlight it a bit more, talking about my favorite thing of the Android SDK, which is like, you see the USB manager, right? This is the service. This is the one we use and we know from the Android environment. And it has a device list on it. And luckily, this device list happened to be a map. Okay, so it's a device list that is a map. I'm not sure why it's called this way, but that's what I meant with my favorite feature. Naming is hard, and that's one of the instances where it's very hard. So in order to get an actual list from the map, I call device list.values in order to get the actual USB devices connected by the help of the USB manager. And then you see the first or null, where I'm actually filtering through all of the USB devices by its product name. If I find the product name Piromoni Badger 2040, then I know this is the digital badge I want to handle with, and I can return this or do other things with it. And you see how I'm formulating this one. This is very, very platform specific. So like there is hopefully no other one who calls a map a list. So this needs to be on the Android part of things. But then we can also have something like an Apple Batch Manager, right? So this is now jumping over from the Android parts of things to the application running on my Apple Mac, right? So this is like this thing standing here you can't see, but trust me, it's a Mac device. And there I need to do different things, right? So in this case, in order to find out the batch connected, I use the iSerialCom library from Facecast. Sorry if I butchered your name. Please feel free to follow them because their library is amazing. And there I can use, like then, if I have a batch I found, I use the open port and wait for 300 milliseconds, and then set DTR, baud rate, num data bits, num stop bits, and parity. Disclaimer, I'm having half of an understanding what all of those words just meant, especially with the set data transfer rate, I think is what it's meant. They are based on the most professional way how you can elaborate things, trial and error. Those are the values you need to set on all of the platforms, but specifically here on Mac, you have to use the iSerialCom library, set it this way, and then you can communicate with the batch on your desktop machine. obviously, I was taking it way too easy, so let's make it more complicated, right? Because we can make it easier. The Linux and Mac platform are differentiating only by the name of the files they're using to to show there's a USB device connected, right? On Linux, it's a TTY. On Mac, it's a CU something something file in the /def folder. So if this is the only difference and the calls to the batch managers are the same, we can use one of our second most liked approaches, which is called abstraction. So we are abstracting the Mac and Linux modules that are platform dependent by the JVM module, which does the communication and gets from the Linux and Mac specific parts the names of the files, so to say. Cool. So this is like hopefully again nice boxes here, but let's add more details to how would I do this dependency between modules. Here I decided to make those modules depend on each other by using the source sets. So this is the build Gradle file where I say like, hey, in the Kotlin part, in the body, find out which operating system you're working on. And if it happened to start with macOS, let's assume that this is macOS system you're working on. And then we can create, based on this information, create a new source set that is called Mac, and this is a JVM source set. And we can do like the Java-enabled things on it. Which also allows me to find out if you're happening to be using a Windows machine, then I can throw an exception in your face. I really like this one. When you try to build it on a Windows machine, it should actually pop up a PR link for you to add your PR to it so that you can make it run for all of us. But let's just go with this one for now. We can differentiate those platform modules by the OS that we are getting from the systems property. Now that we have the source sets defined, we can also specify the dependencies between each other, right? So we have the big commons module, which does like all of the main things. Then we have the JVM specific ones, which is saying like, hey, yeah, take a file. And if there is a file that is the batch, just like do your things you need to do with it without needing to know what the file name is. Because the file name, again, comes in later. We set the dependencies from the JVM main to the common main by just specifying it like it's written there on the big screen, right? So you're saying that the source set of the JVM main is depending on the source set of the commons main, the common main. And that's also the approach we are taking for this one. Again, we are filtering by the operating system that thing is currently building on, and then find out like, okay, if we happen to be on Mac or Linux, then we can add our specific dependencies for Mac or Linux, but also make the source sets dependent on each other. Nice. So this was all building and beautiful boxes. Let's see some more code in like how do the platforms differ and how do they use Compose and other things. So also, I'm an engineer by trade. I have no skills about UI and UX. I'm sorry, you have to stick with me. But I don't know if I'm bringing this point across too often. If you want to help, you see every help is needed. If you happen to have any skills in desktop UX and UI design, please help. Thanks. Otherwise, it will end up like this. So like you see here a beautiful screenshot or not of the desktop app that has like the layout of a digital badge already on there. You can type your name where currently my name is standing. You change it, and then you hit the send to badge button, and it will actually do the deed of sending it digitally over to the badge. What is nice here that this is also using Compose, right? So if you're taking a look at the source code on the side, this looks very familiar. I mean, I have to admit, the window here works a bit differently than the window on Android, but let's just call it a surface or something in our mind on the desktop part. I can set a title, I can set an icon with the painter, and then I can like make also view models and make dependent decisions on the view model, which state should I render and how. Interesting difference here is if you're seeing just the first line there, I actually put a file name there. right? So like if I want to create a painter of a painter resource, there are no resources on desktop JVM Compose as far as I know. So you have to use actual files with file name extensions. It's then also getting interesting, like how do you then take those images and make them platform independent? But yeah, we can figure those out later. But yeah, overall, it works kind of nicely. I can also use other technologies I know from the good old days before, right? But in order to actually create an image that represents the badge we were seeing on the screenshot before, I have to create a panel, right? We remember panels from Swing, I think. But luckily with Compose, we can say like, create me a panel with the composable inside. And then we go to the part I'm not proud of, but at least I made it work, so that's why I'm proud of it, is that I take this panel, put it into a J-frame, put the J-frame centered on the screen, use robot to take a screenshot of the center of the screen by the size of the badge, and then dispose of the window. The nice thing is, if you're seeing this one in action, you actually see like for half a second or half a millisecond, I don't know, you will see it that there's actually a window popping up just because they need to render it into a buffer image and then bring it over to the rest of the library. So taking screenshots, it's actually easy with this kind of thing, but I would have loved to have a composable that I can just tell, give me your screenshots without having this way surrounding it. But yeah. It's nice to see the flickering, and it's nice to actually have the result of saying, hey, I have a desktop app that can render a badge, and I can continue loving it further. Same love goes also for the terminal app, right? The terminal app is, like you would say, it has parameters. I can give it an input image, I can give it an output image, and I can say what it should be doing in between. Sadly, there is no compose yet used on this one. I know that there is a terminal compose, but I felt this is a bit for a one-shot terminal app where there is no UI or no interaction except for arguments, not really the need of making a compose app in here. Instead, I decided I can define my command line and arguments as the class you see on the side in the code part. Say like, hey, what is this argument about? Give me a description so that I can also render a nice help screen if I like. And then you also see the last line that has meaningful code in it is send buffer to batch, right? So this would be a function that is called by the terminal app that goes over the common module and then ends up in the JVM and maybe the Mac or the terminal platform dependent code to actually create the batch and then send it over to the batch. And this is one of the results, right? So I made it by just like calling it on a random image I had generated with DALL-E 2, sorry, not 3 yet, but you know. And just say like, hey, how would this look if you use the Floyd-Steinberg algorithm on this image? And I don't know, for the functionality, it's kind of nice. I have forgotten to mention one thing. I happen to work at a Magenta company called Deutsche Telekom, and we won't stop till everybody is connected. And I took this flag and just ran with it because not everybody yet is connected with our badge, right? Not everybody's badge can be connected to us. So I need to change this and think about what is currently stopping users from connecting their badge. The thing currently is they need an app, right? They need the Android app, they need to install a terminal app or a desktop app. So maybe there is a way to use the algorithms and the love we put into the app to also bring it over to more without having the friction of installing something. And in this case, I thought like, hey, maybe we can use something called Web Serial. So obviously, I'm going for the website kind of approaches, and I found that there is an API called Web Serial that allows me from the browser to communicate with serial-attached devices, right? And this is exactly what the badge is, right? So like I have the badge connected to the Mac, and then I have the browser running on the Mac, so I can make the browser talk to the badge through Web Serial API. Plus, also it's done by Lego, right? So like if you happen to play with Mindstorms, this is the way how you can program on your Chrome browser the Mindstorms while just having them connected to it. It's Web Serial or Web Bluetooth, one of the two, depending on which you're deciding. And everybody has a WebKit browser, right? Excluding Safari, that's a longer story. But if you have Chrome, Edge, or Opera, you see on the side, those APIs are available for you. If you don't happen to have one and using Firefox, luckily Firefox is open source, so please feel free to make a PR for that one. Yeah, so exactly. So this is the way I want to explore more. And the idea is that I just have a website, right? So like I have a random JS file somewhere that I need to host somewhere, and it does all of the communication. It goes the whole way through the described process, the application, the library, and the platform-dependent part. But wait, I'm using int buffers everywhere. Int buffers is like very Kotlin specific. And I'm happy to hear feedback on this one, but I haven't found a way to use Kotlin Multiplatform, Kotlin JS, to use int buffers. Like there's a similar concept in JS, which is, I think, byte arrays called, but it's not the same. So I haven't found a translation layer or something that I can use them directly. So this was when the first monster kicked in yesterday. I thought like, okay, cool, but like we can just over-engineer it, you know? Like why have just one JS file running around somewhere if you can have a random API that also delivers you the front end that then calls the API itself again in order to generate the serial string I need to then use web serial to communicate to the batch. Right? I mean, again, there's Python still missing, you're right, but let's go over the next steps. So again, beautiful boxes. For some reason, they're moved a bit to the side, but this is like displaying a bit how I thought that the architecture could be. Again, we have the JVM part, so far nothing surprising, but now we also have a new entry point for the user, right, which I called the server. So the server can be delivering either a JS script, right, by just going for the root part of the server, or delivering an API that does the dithering and everything I need for image transform. Everything I need the int buffers for, I cannot express in JS. So the split is following, right? So like once I have found something that cannot be expressed in JS, I put it onto the library path of the server. If I found something that is expressible and needs to be expressible in JS, I put it in the new JS module. So this one will contain the web serial APIs, will contain beautiful rendering of UIs on the website. And it's like a fascinating split for me because I was able to use Ktor and my non-existing JavaScript knowledge. It's a great combination. But also I generated an API in the middle, right? So this API obviously is able to not only render one image somewhere, but I added the facility to render Floyd Steinberg, other algorithms, and you can chain it up nicely by just calling the right way. So currently it's running on the local host in this example, but I can use the Floyd Steinberg and get any image I have on my hard drive, base64 encoded, and send it over as the payload in the JSON script. And what I get back is, again, JSON encoded PNG from my API that I then can save once it's decoded into an image and can look kind of nice. But I can also not only work on images, but I can use the Ktor server to also give me the string I need to communicate to the batch in order to display a different thing. So what I needed to change is just from PNG to bin, binary, could have been serial or something else, and keep the same arguments, but then the response will be the string preview : whatever we defined before as a payload. Nice. So this is the API, right? But what is the API without making it user interfaceable, right? So like we want users to be connecting their badge to it as easy as possible. So we also need a website. The website in this example is hosted under localhost 8000 and just returns me a JavaScript or HTML index.html file, however you want to call it. And then inside there, in the JavaScript code, you see something like, yeah, give me the canvas. I take the canvas and get the context in 2D, and on the 2D context, I can actually draw things, right? So like I use this one to generate the bars, the text on the bars, and actually also the name of the user using this one. And then I can also like call the API by just using a fetch with the post method and the payload we were just seeing also in the curl call. And once I get this one as a response, I can also then open the port I get from the web serial API to send it over to the batch with almost the same parameters as we used on Mac before. Ignore the baud rate, it's fine. You know, I don't know what's happening there, it's okay. It works, and that's the important thing. Right? So we have the rendering of the badge, we have the displaying it onto the website, we have the communication with the just created APIs, and then we can actually send it over to the badge. And as you can see, this needs to use the Ktor, or I use Ktor as the API provider, right? Because it's Kotlin, I kind of like Kotlin for some reason being in this conference here today. And I just say like, okay, the API image bin actually looks like this, right? I receive the image from whatever the JSON body I received was, and then create the payload. This lives in the library part of the whole system, right? Creating the payload is what all of the batch apps do, right? It does the Android app, the terminal, all of them need to create a batch payload somewhere. And in the end, I just return the batch command from the batch payload. Easiness, right? And I can do also like some more things, which is like then displaying it nicely. or trying, you know? Again, viewer's discretion. So this is the app running on my local host currently. I can change the name Jane Doe, I can change the size of the texts, and I can change the contact addresses, which in this case is just a teaser for the address of the GitHub repository where all of this lives. But this falls short just a minute for what was our actual goal, right? This still means I need a local host. So I still need to install it. So a second monster kicked in. We have now a URL. Thebadge.cloud is where the Badge app actually is living-ish. So you saw, like, I was using localhost for the development, but localhost is by default secure. If you are using a URL that has not SSL certified or doesn't use SSL for internet things, it's not going to be a secure site. You need a secure website in order to use the web serial APIs. So rest assured, I will read on more about this one. But maybe it's also just that I have to wait 72 hours till like all of the Google Cloud, Squarespace, SSL certificate generating things where I have even less idea than the baud rate of my serial badges till they get through, right? So the idea here is keep the idea alive that at some point the badge.cloud will be living and you can take your badge onto your Chrome browser and modify it however you like. Just because I like the animations, let's think a bit more about the future because we are also getting into closing notes of the talk. Anybody likes Knative? Because if you're raising your hand now, you have to be aware that I want a PR from you. Right? So like, I'm thinking there is a lot of value that we can also like just go down deeper, explore all of the ways how you can create badges, how the dithering algorithm can work. Also, just the inventions of names is fascinating, right? How about badgulator? And emulator that shows the badge, right? So like we have the Python code on the GitHub repository. Can we make an emulator so that if you happen to not have a badge yet, I mean, come on, then you could run them already there and just simulate how the badge would behave without having an actual badge. Also, I don't know who put this last question there because I don't inherently understand it. What is too much? Is this thing enough? Obviously not, but is it too much? But yeah, animation skills once more. So we've been able somehow to make more people use the badge, but obviously I want more. And for that one, please feel free to follow the DT developers GitHub organization. There is currently the JS code in there. And now I'm happy to look forward to your questions, your comments, and anything in between. Thank you.